Hi and welcome to Section 3, Predictive Modelling. In the previous section we looked at constructing a classifier. In this section we'll discuss predictive modelling techniques using support vector machines. We will learn how to apply these techniques to predict events occurring in buildings and traffic on the roads near sports stadiums. Now we move on to the first video of this section that deals with SVM classifiers. In this video we're going to take a look at using SVM to build linear classifiers. SVMs are supervised learning models that are used to build classifiers and regressors. An SVM finds the best separating boundary between the two sets of points by solving a system of mathematical equations. If you're not familiar with SVMs, here are a couple of good tutorials to get started. One is web.mit.edu, another is supportvector.net, and lastly svms.org. Let's see how to build a linear classifier using an SVM. So let's visualize our data to understand the problem at hand. We'll use svm.py that's already provided as our reference. Before we build the SVM, let's understand our data. We'll use the data_multivar.txt file which has been provided to us. This is the data it contains. Let's see how to visualize the data. Add these lines to svm.py. Here we just imported a couple of packages and named the input file. Let's look at the load_data method in utilities.py file. This will load the multivariable data in the input file. Now we need to separate the data into classes. These lines will do it. Now that we have separated the data, let's plot it using this code. I'm now running the code using this command. Oops, there's an error. We'll go back to the editor, just uncomment this and try again. Yes, this is the plot of input data. It consists of two types of points, solid squares and empty squares. In machine learning lingo, we say that our data consists of two classes. Our goal is to build a model that can separate the solid squares from the empty squares. Let's see how we can do this. We need to split our dataset into training and testing datasets. Add these lines to the same Python file which will do the needful. Let's initialize the SVM object using a linear kernel. If you don't know what kernels are, you can check out www.eric-kim.net. OK, so we'll add this line to initialize our SVM object. Now we're ready to train the linear SVM classifier. We can do that by adding these two lines. This line will show us how the classifier performs. Now let's run this code. We'd need plot classifiers for this. OK, so when I run it again, here is the training dataset. Let's see how this performs on the test dataset. These are the lines of code we need to add for testing the dataset. OK, so let's run this code. Here's the output for the test dataset. Nice! Now we'll compute the accuracy for the training dataset and testing dataset. For that, add this block of code. Let's run the code. You can see the output. This is for the training dataset. And this is for the test dataset. Awesome! From the figure where we visualize the data, we can see that the solid squares are completely surrounded by empty squares. This means that the data is not linearly separable. We cannot draw a nice straight line to separate the two sets of points. Hence, we need a non-linear classifier to separate these data points. So that's all about linear classifiers using SVM. Great! In the next video, we'll take a look at building non-linear classifier using SVM.